This is part 4 of the series of tutorials for constructing our Drive app. It is also the second one in stage 2. So by the end of the previous part, which was part 3 and the first one in stage 2, we got to the part where we were supposed to create a script called Drive main script and attach it to the app manager. That can be done by selecting the app manager and clicking add component, or right clicking create mono behavior script and then attaching it. One way or another, we have a Drive main script and it's attached. That's one more way to do that, to the app manager. So I hope that between the last part 3, and watching this one, that you have created that script and also typed its code. I'm going to open it so we can start this tutorial by explaining it. Drive main script. That's basically the script that makes the car go, that makes the car drive. It has about 60 lines. Let me bring it in. Too small. Okay. So again, I have it typed already. Hopefully, by the time you're watching this video, you've typed it too. Let's go over what's in that script. As far as using, which are the libraries, it's the regular Unity engine plus one more library called Scene Management, because one of the things that this will take care of is reloading the scene when we fall into the ocean that we have not created yet, but it's for future use. The other thing that this script has, as we done many times before, is a class, public static class called application data, and that's going to include variables and objects that are accessible by all the other scripts. Static in this case means that it can be declared by this script, but it cannot be deleted or change type by other scripts. They can only give it values or read their values. So what variables are we going to have that are going to be shared by multiple scripts? Hit ocean floor, which is going to be a Boolean. That's going to say whether we fell to the ocean floor, which of course this would indicate that it's time to reload the scene. Before we hit the ocean floor, we're going to make a splash on the water. So that's also a Boolean. One that's going to be very useful is going to be called current z velocity. Z, of course, is forward. The velocity forward and backward. Without turning this into a long lecture about physics, velocity a lot of times is a word that's in popular speech synonymous with speed, like what's your speed, what's your velocity, but it's a little different. Velocity is actually a combination of speed and direction. So z velocity is speed in the direction of z. This is why there's also another float called y velocity. Y velocity is up down. For instance, the speed of falling. We're going to add more later on, but for right now those are enough. This script is going to evolve. So this is the end of the application data. Then the public class of the script itself, which of course, as we know, needs to be spelled exactly like the name of the file. Then there's some variables that are specific to this class. They're not application data. They're used only in this class. We're going to have a private. Private simply means that it's not going to appear in the inspector in Unity. It can be used within this script, but it's not going to have a field in Unity. Called horizontal axis, and another one called vertical axis. Now, those are going to be a number. Simply putting it, if you are going to be using, let's say, the joystick on the left controller, when the joystick is at rest, the horizontal axis is 0. When you push it all the way to the left, it's -1. When you push it all the way to the right, it's +1. And of course, all the range or the spectrum of values in between, like, -half, +half, and so on. Same thing with the vertical axis. The vertical axis is pushing it forward or back, and at rest, it's 0. That, of course, is going to indicate or get how much we're pushing it. Then there's going to be a public game object called player. In other words, if we're going to move something, who is the object to be controlled? Then there's going to be a float called forward force, which is going to be the horsepower of the engine. I made it public so we can play around with it. As we said before, it's going to be a combination of how much horsepower are we giving our car versus how heavy it is. Of course, if it's lighter, we don't need that much horsepower, but it's going to be a little less controllable. If it's heavier, we need to give it a lot more horsepower just to get it moving, but it's going to be sluggish. So a good combination between them makes the whole experience of the game. Then, since our wheels are also going to be turning, when I say turning, I'm not talking about spinning forward. I'm talking about like a turn left or a turn right, like when we use the steering wheel. How strong is the turn force or the steering wheel? Just like in a car, your steering wheel is connected to the turn of your wheels, but not directly, right? If you turn your wheel 10 degrees to the left, your wheels don't turn 2 degrees. It's hydraulic. There's a ratio between them. Sometimes you have to turn your wheel like almost like an entire spin, 360, for the wheels to turn let's say 45 degrees. So that's going to be the ratio between them, the turn force, or the angle that your steering wheel, your imaginary steering wheel, is going to turn the wheels. Then you'll notice that the rest of the script is within the function update. Don't forget that update needs to be with a capital U, which means everything from now on is going to be checked or tested 72 times a second, because that's the frame rate of VR. 72 times a second is going to ask, what is the horizontal force? By asking input, get axis, horizontal. As a matter of fact, it's going to be checking, and this is the trick of this game. The horizontal value can come from more than one place. It could be either the joystick on the left, or it can also be the left and right keys on the keyboard of a desktop or a laptop, because we're naming it horizontal. Now, how does it know what horizontal means? This is because, going back to our settings, if I go Edit, Project Settings, one of our project settings is called Input Manager. One of the categories is called Input Manager, also known as the Old Input Manager. And under the Old Input Manager, there's already predefined. You see horizontal with a capital H, vertical, and if I unfold horizontal, it specifies exactly what constitutes horizontal. It can use the left and right arrows on, like a computer keyboard. It can also use the A and D key, as in traditional PC games that use WASD. A and D are sideways. And it can also use the mouse, and most important, it can get motion from old joysticks. So it's an incredibly convenient way of defining horizontal push, horizontal force by almost any input. It'll get an input from left and right keys. It'll get input from A and D keys. It'll get input from any joystick, and that also means that if you get one of those, $20, game controllers that you can hook up with USB to your computer, that'll also play the game. This is what makes this game both a VR game, but also a PC game. Same thing, of course, for vertical. Vertical will be the up and down keys. It'll be the S and W keys on the keyboard, and of course it'll get motion from all joysticks. So if we go back to the script for a second, when it says get axis horizontal, it can get it from whatever platform the game is playing on. If it's on Quest, it'll get it from the joystick. If it's on a computer, it'll get it from the left-right keys or from the WASD. One more thing to make sure that this all works, one of the things that we did when we created the blank or the empty template is in the player Let's check that right now. In the player settings, in the category called Other Settings, we need to make sure that the input setting is used right here. Active input handling is defined as both, because it has an old one, which is the one we're really using, and the new one. Now, it kind of recommends changing to the new one, but if we change to the new ones, it will only pay attention. It'll only be a VR game. It'll only get input from the joystick on the controller of the Quest. If we use both, and I tested it, it works, it'll get input from both the Quest controllers, but also from keys on the keyboard, which will allow us, not only to develop this parallel at the same time for Quest and for PC, but also while we're developing will be a very, very easy way to test, let's say if the car is moving, without having to build to the Quest all the time. Going back to the script. So this gets the value, and it's going to be somewhere between -1 and 1. If it's not pushed at all, it's 0. If I'm pushing the left one, it's going to slurp or slide into -1. It's not going to change dramatically from 0 to -1. It's going to be like from 0 slide into -1, or 1 if I'm holding the right key. Then it's going to ask a bunch of questions. What to do? If vertical axis bigger than 0, what does that mean? That the user pressed the W key or the up arrow, or he's holding a joystick and pushing it forward, he or she. In that case, I'm saying, hey, whoever's the player, please get component constant force and change its relative force to be a new set of 3 numbers. We're not going to change the X. We're not going to change the Y, but we're going to give it whatever forward force we have defined. Remember, the forward force is one of our variables right here. It's a public, and we're going to populate it, basically with a number of horsepower. So basically what it says is, if the vertical axis is bigger than 1, then give it whatever horsepower it needs to have forward. If vertical axis is smaller than 1, which means it's in reverse, down arrow, we're going to give it the same force, only in reverse. Relative, it's very important that the constant force is in relative, so it's in relative to whatever it's facing right now. Just like in a car, if you're being told to, like say, turn left and then go forward, it's forward relative to your last left turn, not to the world. The third question is, or the third if, is what if the vertical axis is 0? We have to take that into account, that it could be a positive, a negative, or it could be a 0. Vertical axis 0 means that there's no gas, that, there's no forward, no one pressed anything. In that case, we're going to actively change, especially this one, the Z1, to 0. So it's giving it all zeros. It's going to glide a little more, just like a car, from the inertia of whatever previous motion it has, but it has no more power of its own. So it's going to gradually stop. Then the same 2 questions about left and right. If horizontal axis smaller than 0, what does that mean? That a user pressed the A key or the left arrow, or they're holding a joystick and they pushed it to the left. In that case, we are not moving it to the left, we are turning counterclockwise. How do we do that? We say my player, which is the vehicle, the car, .transform.rotate. Vector 3 down simply means that we're rotating around the y-axis. Remember, it's like a revolving door, but down means counterclockwise. By how much? Time.delta time is the fraction of 1 frame, like 1 divided by 72 of the turn force, which means if the turn force is 35, for instance, then it's going to complete 1 divided by 72, a 72nd of this number in each frame. And in 1 second, it's going to complete the complete 35 degrees. Times math, absolute, horizontal, axis. Why absolute? Because we want to make sure that we are always, otherwise we'll have a double negative, because down means counterclockwise and we're pressing left, and that's also going to be a negative. Negative is going to make a positive, and instead of turning left, it's going to turn right. So abs means absolute value, which means, you're turning to the left, it's like negative half, but we're just going to consider it as half and counterclockwise. In my words, in my comments, I wrote, hey, player, rotate a fraction of, let's say turn force is 35 degrees, the absolute values, and y is always negative because it says down. The other if question is exactly the same, only if it's bigger, which means we used one of the ways to indicate we want to turn clockwise or right by pressing D or the right arrow or the joystick being pushed right. And it's exactly the same line. Notice the difference. Vector 3 up. Up is also the y-axis. When I roll over it, you can actually even see that it's shorthand for writing vector 0, 1, 0. No x movement, y movement positive, which means clockwise, and no z movement. How much? Whatever fraction of frame we're on times the turn force. Again, absolute, because we want to make sure that it's always positive. In this case, because we're turning clockwise. All these 5 statements are about going back, forward, turn left, and turn right. And then there's something that's going to be used in the future because we haven't built it yet, that if the application data says that we hit the ocean floor, how is it going to know we hit the ocean floor? Because we're going to have an ocean floor that's going to report a collision. Going to be reported by the ocean floor script. So if we hit the ocean floor, first thing we say is we turn it back to false so we don't have like a multiple touches and prevent it from looping and touching. And it's time to go back to reload the scene, because if we fell down to the ocean, it's time to try another round. This is the end update and the end class. Hopefully you've written all this already. And if your script shows, like if I go back to Unity and go to the console, I should be able to clear. If there's errors you can't clear, that means you have typos, so fix them. Assuming you don't, or that you fixed them and came back. Going back to the guide, we have typed all of this code, and either we did it before or after. This script is attached to the app manager object. In the inspector, we're going to give it the following parameters. Notice there's 3 public parameters: player, 2400, and 35. Let's explain each one of them. So app manager should have 3 public fields. Player is my player. In other words, all that force, who's going to move? My player. Forward force, that's the horsepower of the car, 2400. By making it larger, I can make the car move much faster, but then it's going to be a little harder to control, and vice versa. The turn force is, I'm just going to use the number 35 because it's very typical for wheels of a vehicle to turn about 35 degrees when I, move the steering wheel. No car moves 90 degrees. We can play around with that to make the car turn more like, what's called, turning on a dime, or more, sluggish. At this point, if I go back, play in Unity, the vehicle should move. Use arrow keys or WASD because I'm on a keyboard. The wheels don't spin yet, but the car does move. Let's see if I forgot anything. So if I play, and it goes into play mode, sometimes it takes one click on the game window to put it in focus, even though the mode I have in it on is play focused. And then I'm using, in this case, the arrow keys. I'm going forward. I'm going back with a back arrow. I am also using the right arrow, and it's turning. I'm using the left arrow, and it's turning. While it's playing, you can, play around. Let's say, what if it was, not 2400, but 24,000? What that would do is that this would fly forward in a way that oh my God, I can't stop. The only way to stop this vehicle is actually to put it in reverse. So it's fun to, go fast, but it's a lot less controllable. So go. What if it was only 2? Then I would push the arrow forward and it's not even moving. Why? Because my forward force is not enough to overcome the friction of that physics material we called road. So I'm going to return it back to 2400. I just found, by experimenting, that's a good, compromise. And the turn force is how many degrees will it turn per second. If I make it only 3 degrees, that means that when I press the right arrow, it'll take it a whole second just to go 3 degrees. See how slow it is? That's not really drivable. On the other hand, if I made it 300 degrees, it would turn way too much, way too fast. It'll be very hard to point it at the right direction that I want. So I made it 35 after, just experimentation. These are the things we can always change by the time everything is done, by the time the game is, done. That's why I made it public, so it's easier to experiment with whatever values we want. Going back to the guide, it also says that anyone who has access to a Quest device, this will be a good milestone to try building, because that way you will be able to use the joystick or the left controller to do exactly what we did with up, down, left, right keys or WASD. The one thing it reminds people who have access to a Quest device is that if we're going to build, we need to build this scene. So we got to make sure that we go File, Build Profiles. You see how right now it wants to build Drive Stage 1. So I'm going to click Open Scene List and either drag, if I have it available, the scene Drive Stage 2 here, or just add open scenes because that's the open one. But making sure that I either disable or right click remove. So if I build to a quest, I'm going to build the scene that I last worked on. I'm going to stop this tutorial at this point and go back to part 5, which is going to be the third one in stage 2, for explaining the other scripts, the ones that are going to be used for making the wheels spin and also making the wheels physically turn. Because right now, when I drive, the car might be moving, but it feels weird that the wheels are kind of, stuck. And when I turn right, the car is like, the car's rigid. It looks like a toy car that, like a cheap toy car that doesn't, move its wheels or turn its wheels. That's what we're going to add in the next part.